And today I will be covering the topic the functional safety for motorcycle application, which is a part of ISO 26262, and it's coming under part 1. Okay, let us go to the topic. Okay, so this is overview. This is an overview about part 1 ISO 26262, and you know that uh, the functional safety is very much important for automotive application, and this has been dealt with ISO 262 standard. And you know that it is meant only for road vehicle, which is weighing up to 3,500 kg. And this part 12 is specifically, as I was mentioning, this is for a motorcycle application. But again, it is going to be a micro motorcyclist, which means the person who is riding the vehicle. For them, this is meant, because in order to prevent him from the accident or the risk related to the fault or error of the automotive components. Okay, uh, and you know that motorcycle is not been excluded explicitly in the standard, but the standard was been more specific for the passenger vehicle or the car application, which is from part 1 to part 12. And now we are going to see the application of part 12 for the two-wheeler application. Okay. You might be asking the question why the part 1 to part 12 is not covering the two-wheeler application. Um, so this is all of, just a quite few points. You know that there are many components in the car, and uh, you also have different components in the bike application, where the application wise it might be same, but it calls for a different hazards. Okay, so you cannot compare the rating or the severity of two-wheeler braking system to that of a four-wheeler braking system. Even though the application remains same, um, you cannot compare apple to apple. Okay, so the application is, even though the application remains same, but you, you, you can able to find a difference between the application of a car brake and then with respect to the bike brake. Okay, and the rating also varies, right? You know that we deal with the severity, occurrence, and then the exposure, what you have seen in SLA, SLB, SLC, and SLD. So in the case of motorcycle, you have MSIL. So in the case of a four-wheeler application or a car application or a passenger vehicle application, you would have seen as quality management, SLA, SLB, SLC, and SLD, where the automotive severity index integrity level. But here you are going to deal with the MSIL, which means motorcycle severity integrity level. So it's totally a different concept here. So that's why it's not been dealt in part 1 to part 11. And it is what here you are going to see that this is going to be completely a different scenario in the case of motorcycle. And because of this reason, uh, even there are different parameters. There is a difference, and we can also see the operating condition also varies between a four-wheeler and then a two-wheeler, and hence we need to have a uh, different safety guidelines. That's why this part 12 has been covered here. So let us see the difference between part 1 to 11 and then the part 1. So part 1 to part 11 is part of ISO 26262, and this is also a part of ISO 26262, which means we are not neglecting the motorcycle away from this ISO 26262. But part 1 to part 11 is going to deal with the heavy vehicles, which includes buses and trucks. Even for car application also this is been applied. And the part 12, as I was mentioning, this is only for a motorcycle application. And you know that I was telling you about a SIL, where that is applicable for a risk classification A, B, C, D, which stands for automotive safety integrity level. Whereas here, in the case of part 12, we are dealing with motorcycle safety integrity level, which is a short form of MSIL. And you also know that this ASIL is being derived by HARA, okay, hazard analysis risk assessment. So this is ASIL. We are deriving the ASIL with the help of HARA. And whereas here, in the case of MSIL, so this is derived by not only it's derived by HARA and it is mapped to ASIL. Okay, and so here how we are going to map. Okay, so you see here in the case of ASIL rating, we are having QM A, B, C, D, right? But in the case of MSIL, what we are going to have is we are going to have a rating such a way QM A, B, C. Okay, we are not going to have D rating because uh, as I was mentioning you that this this part D is totally sorry, ASIL D is totally been eliminated here uh, because this because of the comparison between MSAL and then the ASAL. Okay, and we also know that D is the highest ASIL rating. The case of the passenger car and also the buses and truck application. And whereas here in the case of motorcycle, we call C as the highest ASIL. Okay, which means when the severity is high, when the severity is high, we call C is the highest ASIL. Okay, C is the highest ASIL. Okay. Um, mentioning is part 1 to part 11 is for the heavy vehicles, for buses and trucks, and even for cars. Part 12 is for motorcycle. And we know that we have the ASIL risk classification in the case of part 1 to part 11. In the case of part 12, we have risk classification as MSAL, which stands for Motorcycle Safety Integrity Level. And ASIL is derived by HARA. And you know, this MSAL is also derived by HARA, but again, it is mapped to ASAL. So let us see how the mapping is done. The mapping is done such a way QM of ASIL is equal to QM of so let us go in different way. So QM A, B, C, D we have for ASIL, but in the case of motorcycle we have quality management A, B, and C. Because C is the highest ASIL. Okay, because we don't have many features as like of four-wheel application. You know that you also have anti-lock means you have features like airbag deployment, which is not there in the case of motorcycle. Um, so and even so you also have ABS in most of the four-wheel application. Even you have the ABS in the case of two-wheeler as well, but some motorcycle they don't have the ABS. So considering all the criticality, the ASIL level is been reduced from D to C in the case of part 12 application. Okay. Okay. Let's see the features of motorcycle which are getting covered with respect to the part 12. So it just covers the general topics which is been used for adoption of for the motorcycle, and it also going to deal with the adoption of the safety culture. Okay, so safety culture is very much important, and that we have seen in the case of part 1 to part 12. So this safety culture is also being followed here as a part of part 1, and then we are also going to see the confirmation measures which have been taken to ensure the safety is being met. And then we are also going to see the HARA hazard analysis and risk assessment, similar to what is there for a what is there for a four-wheeler application. And then it also going to cover the integration and then testing of the vehicle. And finally, it is going to cover the safety validation. So these are all the points or the topics which is being included as a part of the standard um, as in part 12 basically. Okay. Uh, We also know that the starting point of anything is going to be hara. Okay, and then after we analyze the hara, we are also going to see how the vehicle is being integrated and how it is going to be tested. So when you say integration, you have the development of hardware, software, integrating that, and then how you are going to test. So that's where challenging. Say for example, I can give you one example of a two-wheeler application. Say when you take a cluster, okay, so cluster is similar to the one what we have seen for instrument cluster in the case of four-wheeler application. You also have the cluster for two-wheeler application. Okay, so where it will show you the vehicle speed, it will show you the vehicle speed, and then also it shows you some features, some application like map also you can take into consideration. Okay, even for a two-wheeler application, you have the map where that can be seen with the help of a cluster. So here what you have to do when you're developing the cluster, you have to do the design verification plan, not only with respect to hardware application, even the software application also to be taken into consideration. And you have to integrate both the hardware and the software application. Um, and then you should test it. And you also see what happens. See, I will give you one example. If the original speed of the vehicle is going to be 80 km/h, but if it is showing only 40 km/h in your cluster, so there might be some fault. Okay, it can be with respect to the software, or it can be with respect to hardware. Okay, so again, when there is an indication of wrong kilometer in the case of a cluster, this also calls for a safety issue. Okay, and this also a kind of risk, like hazard, or I can say this it will lead to a severe severe failure again. So this type of things to be tested in such a way, those failures are not going to happen at the customer side. And the OEM also going to ensure that the manufacturer is also going to ensure that the safety culture is being followed across each vertical. It can be the hardware or software or integration of both. And then they are going to validate such a way. It is going to give zero of safety failures basically. Okay. This motorcycle is going to have a unique functional safety requirement. Okay, and it is also going to emphasize more on the rider behavior. Okay, the rider behavior is very important than the vehicle components. See, vehicle components for two wheeler or four wheeler is going to be same. Say even the frame is applicable here. It's going to have the chassis. It is going to have the steering system, suspension. Okay, uh, even it is going to have if it is electric vehicle, it is going to have the battery, and if it is going to be the engine, in its size, it's going to have the engine. Okay, the components remain same, but what happens? The rider behavior is going to be different. But again, the load pattern also going to vary. Okay, so I'm not commenting on the load pattern. You cannot compare the two wheeler with respect to the four wheeler with respect to the loading pattern, or the strength point of view. We cannot compare, and also the performance also cannot be compared. But what happens here? We are dealing with a completely new topic called the safety topic, function safety. The function means it is uh, the function is very much important. You take any component. Taking the frame. What is the function of the frame? It's to support load, right? So what is the negative order function? When you say negative order function, which means the frame is not capable of withstanding the load, or withstanding the load, right? So that is a negative order function. So negative order function is nothing but the failure. Okay. Uh, so when you say that failure, okay, it obviously it calls for, it can be a performance issue or a safety issue, or it can also call for the environmental issue also. It depends on the application basically. Okay. So when you're taking the engine application, you call for BS1 to BS6. Now we are running with BS6, right? Euro 6 you call. So, so if in case if the emission is not meeting, again it calls for a environmental issue. But again, here we are not comparing the vehicle components, but we are defining the functional safety based on the rider behavior. Okay, but of course, vehicle components is also very much important. It doesn't mean that the rider can able to ride in a proper way if the vehicle components are not proper. Okay, the vehicle components is also very much important, like chassis, frame, or the steering system. Okay, you have a different steering, like oversteering, understeering, right? And also if it is both are risk, right? Oversteering is also risk and understeering also risk. So for example, we would have seen during my visit last time there, so I also told you that oversteering and understeering example, where when the vehicle is running in highway, say for example like 80 kilometer per hour, and if the steering is getting locked, okay, you cannot move the steering either left or right, or the direction which the driver want to ride. And again, this calls for a big risk. I mean, okay. And similarly, there is another example when the vehicle is running at 80 kilometer per hour, and what happens instead of medium steering, and what happens if it is over, if the vehicle gets oversteered, okay, even that is also a big risk. Okay, so considering this, I also given you the example there, but that is for a four-wheel application, but which is a part of, again, that is going to be ASIL D category. And ASIL A or ASIL B or ASIL C or ASIL D, it also depends on the rider behavior, right? If the vehicle is running at 10 kilometer per hour, the risk is going to be comparatively much more low than the vehicle when it is running at 80 or 100 kilometer per hour. Same way, also I also mentioned that with respect to the thermal behavior. Okay, I have given an example where when the vehicle is running at 80 kilometer per hour, and immediately there is a thermal event, or a fire is happening in the front cabin of the car. Okay, and the risk that occupant is going to experience is going to be higher when compared to the vehicle when it is running at 10 kilometer per hour, where the thermal event is going to happen. Okay, so when it is running at 10 kilometer per hour, the rider is having the control over the vehicle to stop and then to get down and then to come out of the vehicle. But assuming that higher speed, so the braking resistance and then the reaction time, so those also matters. Okay, uh, okay, so I'm slightly deviating, but the point what I want to convey here is the rider behavior is very much important, not only for this motorcycle application, even for the part 1 to part 12 what we have built actually. Uh, so the latest version of this ISO 2622 standard, it's start from the start, that is the concept phase. Okay, and then for two-wheeler safety culture in the organization, that are basically stakeholders in the motorcycle, which involves the development activities. Okay, and then this ISO 26262 also adapts itself to the unique safety needs of a motorcycle as well. Okay, so now going into the safety culture. So I told the safety culture is a very hot. It's a heart of any development activity. Okay, so when you're going for any development, it can be concept phase, or it doesn't matter. Okay, in which phase you are, right? Uh, but the thing is that you need to have the safety culture across all the phases. Okay, uh, the that's where the companies, the OEMs define the process and also the work instruction for meeting the complaints. So here we are dealing with the part 12. We are considering only the part 12 application with respect to the quality management system. But again, you will have seen the safety culture for part 1 to part 11 as well. And again, it also has to ensure that the other standards are well integrated. It doesn't mean that part 12 is not going to cover part 1 to part 11. Even some of the points in part 1 to part 12 is also part 11 is also been covered here. It's basically you call this as integration, right? And just excuse me if in case if there is slight disturbance because I'm in another one. Means I'm in a place where slight disturbance might be there, but hopefully, if my voice is clear, hopefully you will not feel the disturbance. Okay. Um, okay. So okay. So it doesn't mean that part 12. It doesn't mean that it is not going to cover the concept of part 1 to part 12, part 11. So even we also have the concept phase here, right? And we also have the hara. So we have the ASIL. Instead of ASIL, we have the MS here. Only that difference. But the testing and validation, okay, those things are integration. So it's well applicable here as well. Okay. So it's very important that you should not neglect anything. Okay, so you should ensure that's why it is mentioned that the other standards should be integrated very well. For example, even the software application interaction between the cyber security. Not only see, it's not that you should also respect the cross-functional standard as well. Say for example, so now we are dealing with ISO 26262, which is a part of functional safety, and you also need to ensure that uh, the interaction between the cyber security and then functional safety is also going to get covered. Okay, and just a second. So you should also ensure that the proper measurement is being taken for the process improvement, which needs to be put in place to learn from successfully executing the function safety project as well. And the companies like Tata Motors is a big organization, right? So normally what you do is you are going to give the utmost priority uh, for the motor safety team and for the execution and also for the complaints. So this is the utmost important thing that any OEM can give. We'll be giving to ensure that safety culture is been met basically. So coming back to the reclassification of the confirmation method. So you are going to have classification such a way the confirmation measures have been taken to ensure that all the function safety have been achieved. Okay, so the confirmation measure is the major requirement for execution of certain work products. Uh, so these confirmation measures must include three things. Even you would have seen this in the case of the part 1 to part 12 as well. So the confirmation measures involves the confirmation review. First, you are going to start your review, and then you are going to have the assessment for that, and then you are going to have the audit. Okay, and the main purpose of this review is to ensure that the activities which involves HARA or FMEA or FMEDA are being on the correct track. Okay, so it's a kind of checklist I can say where you're not going to neglect any of the parameters or any of the key activities like HARA is important, FMEA is important, FMEDA is important. Okay, and you also know that some of these reviews needs to be done by a different person. You also have some external auditor as well. Okay, like you have IATF, right? So similar to that, you also have some external auditor where they also take a review, they assess, and then they audit, considering all these parameters. And they also give. There are some confirmation measures which are supposed to be performed by a person within the department, within the company, but a different department. Okay. So sometimes your cross-functional department also will do some audit. Okay. Like it's similar to IATF. Okay, so you have the internal audit and also the external audit, right? Before you face the external audit, you face the internal audit, right? So that's how you also have the similar thing here as well. Um, and this classification is depending on the safety goals and also the ASIL level. And for motorcycle table, see, this is what like I'm going to tell this. We have a table 1 in part 12 is replaced by part 2 table on confirmation reviews. Basically, the ASIL to MSIL, right? So that's what we are going to see that. So here, this table is going to skip the ASIL D column. I told you, right? There is not going to be ASIL D, and ASIL D is going to be missing in the case of MSIL, and you are going to map that to ASIL C basically. This is what I told you. So here the confirmation measures, it measures the confirmation reviews or audit or uh, assessment, okay, assessment and audits. So this should be performed such a way there should be some interdependency. There should be degree of interdependency should be there, right? And again, it's very important that assessment to be see. When you take confirmation measurements, say for example, you have various parameters or activities to be performed with respect to the function safety, right? So the starting point of any failure is going to be error. Error lead to fault. Fault lead to failure. Failure lead to hazard. Hazard lead to risk. Okay, there are 5 different stages. When you say different 5 stages, okay, the starting point can be error or fault. Um, First is a error. Sorry, first is going to be error. Error lead to fault. Fault lead to failure. Failure lead to hazard. Hazard lead to risks basically. Okay. See now when I say error, you might be. My perspective is going to be slightly completely different here. Just I'm going to explain in such a way what you do with respect to the organization point of view. You have PFME, process failure mode effective analysis, right? You also have the design failure mode effective analysis. So what you do is you analyze only the failure modes. Okay. So, but again here, what what needs to be done is there may be a lot of fault which is leading to failure. Okay. You also need to understand the different various faults, and also you should also need to understand different various error as well. Okay. And you also have it doesn't mean that even though if you have error or even though if you have fault, it doesn't mean that the failure will happen, right? All error and all faults will not lead to failure. Okay. Similarly, all failures will not lead to hazard. Okay. And all hazard might or may not this again risks. Okay. It's all depends on the pattern of writing and also the function of the individual components getting performed as a system level, not with respect to the individual component. Okay. So when I say individual component performing as a system, say it can be the anti-lock braking system. Okay. Or it can be the battery system. Okay. Or it can be the airbag deployment system. Okay. Or it can be the suspension system or the headlamp lighting system. Okay. So I'm going to see in such a way as a complete system. So here, so I was telling you, right, all the failure may not lead to all the fault may not lead to failure. So say for example, but again, when I say all the faults or all the errors may not lead to failure, so you need to do lot of assessment, you need to do a lot of review, you need to do a lot of audits. Okay. These three pillar you have 3 pillars for a confirmation measure. Okay. So you are measuring the confirmation. Okay. You are measuring it. So it's basically a kind of measurement. The measurement is based on review, assessment, and audit. See, it is like a kind of you can even you have the I will put it in another way. It's nothing but a safety confirmation measure. How the company is ensuring the safety, or how the organization like Tata Motors is ensuring or confirming the measure of the safety. Okay, it is based on 3 pillars. First pillar is you are going to do the review. Okay. Review can be with respect to the individual activity or individual phases. Okay, you have the concept phase, you have the development phase, you have the integration phase, you have the testing phase. It can be with respect to the individual activity or it can be with respect to the individual phases. So when I say activity, the HARA, FMEA, FMEDA, these are all the activities. Okay, you have different activities like this. So here you are going to have 3 pillars for the confirmation measure. One is going to be based on the review, uh, it can be internal department or the cross-functional department, and then with the help of the external experts as well. And they are also going to, based on assessment, they are going to assess, like, see how you are rating your SLA, SLB, SLC, and SLD, and then you also have various out of box, right, like safety element out of context, right? You also have various various checklists where which needs to be developed, which needs to be taken care uh, by the developer or your supplier. Okay, when you take your developers like Boss or Continental, okay, they themselves needs to ensure that some of the development features are to be developed by them to ensure that safety is being met for you, which means not with respect to component level, as again it should be taken care with the system level and also with respect to the vehicle level. Okay, so that's where the integration comes into picture. So they also do the lot of development, they do a lot of uh, uh, trial and error, such a way they do a lot of testing to ensure that safety is not being affected for your vehicle, for your system, and also for your vehicle. So once they do all these things, so what you do is you also do some design verification plan and validation testing, right? And so this assessment is nothing but the external auditor or your internal auditor will assess whether are you doing the testing, or are you doing the safety culture, what you call. So as per the guideline or not. So they do the assessment based on that. Okay, and audit is again is based on the various thing, like even they also take the internal failure audit also, like you do lot of testing, right? Vehicle testing you do before you launch the vehicle to your customer. What they do is they take the internal failure, say for example anti-lock braking system getting failed, okay, or the same example of steering system oversteering, understeering, or steering getting locked, okay, or the airbag is the deployment time of airbag is going to be not with lesser time, okay, it is going to be higher time, okay. So this if you are facing this type of failure, they also try to audit such a way what is the root cause, RCA, root cause analysis we call. So what is the root cause been taken care, and then whether the root cause has been implemented, and then the proper validation has been done again, and then um, so they do all the audits such a way what is the risk that the company, that organization is giving before they launch the vehicle. So before they launch vehicle, this function safety should be taken in such a way, not only for a two-wheeler or not only for four-wheeler, it should be taken care for all the across all the platform. And this is a part of the thing which is being taken utmost priority by all the OEMs. Okay, and so here what they do is they ensure that the external auditor are going to confirm the safety measure based on three pillars. One is based on review, one is based on assessment, and the third one is based on audit. So these three things are very much important. So that's why, like when I say confirmation measure, these are the things comes into picture. Hope I have answered it. If in case if I'm giving you more examples, it might slightly uh, strike you. So that's why I'm doing it in that way. Okay, so here we have a degree of independency. So which means for this confirmation measure, we need to have the degree of independency. So you have totally 4 points in this. The confirmation measurement should be performed. If not justification need to provide, it shall be performed by a different person. That's where it can be. See, if you are from quality, it doesn't. You can appoint some cross-functional department person to measure it. Okay, and even the external person also. See, and again you see here the confirmation measure shall be performed by a different person. Okay, and the confirmation measures will be performed by a different person that is not reporting to the same direct superior as well. So you have different scenario here. So it should be, you see, if in case if there is no justification needed to provide for the measurement, it shall be performed by a different person. But suppose if you are doing the audit in your own department, what happens? You need to justify, right? But if it is from other person or other department, what happens? You no need to have the justification. If not justification, need to provide, what happens? Because you yourself, if you are from same team, you will also justification. But uh, they, but again, here there is some issues going to happen. Even the auditor may, some it is required by the auditor to give the justification. If in case, if they are not giving justification for neglecting it, say for example, if they feel that if your company is not going to meet the proper documentation with respect to ASIL documentation. Okay, so you have to document, right? I was mentioning you that documentation is important, which means when there is a failure going to happen before you launch the vehicle, it can be the airbag issue, or it can be with respect to the headlamp or any ABS, thermal runaway, anything. Okay, so you need to document it. If in case, if the document is not going to happen, uh, they can, during the audit, the person, it can be the internal person or the external person. That's why it is mentioned as a different person. Okay, that person can also rate that during that, they can also put a comment that there is some lagging of the, the, the SAR or something. They can put a comment, but basically they no need to justify that why they given the comments. But again, practically speaking, nowadays it's very important that all the auditors, they give the justification. Okay, but even though, uh, because you need, they should also be logical, and at the same time they should also give the justification on what basis uh, the comments was given, or uh, uh, the, the points, the safety points is been getting reduced. Okay, so this is how normally, practically it works basically. Okay, and this confirmation measures will be performed by a different department, different person, which is not reporting to the direct superior. That's what I told. And the last thing, degree of independence, it's not dependent on individual, it's going to be independent. Here is the confirmation measures will be performed by a person from a different department or the organization, complete different organization. See, you also have Tata Motors itself is have the different group of companies, right? Even from there also you can take that way also. Okay, which is independent from the department responsibility, and then for the considerable work products, even the management also may vary, even the resources also might vary, and the authority also might vary. Okay, so they can do, which means the audit should be performed such a way, it should be completely a new person. It can be from the internal company or other company, or kind of consulting organization or consultant kind of thing. See, normally this function safety audit is more tougher than IATF, because you need to consider more of safety aspects. Okay, even the documentation, even the root cause, those things should be such a way. Uh, they go in a very deeper way to ensure that the organization is meeting the safety related aspects. Okay. Uh, in, so it doesn't mean that it is applicable only for two wheelers. It is also applicable for a four-wheeler application as well. But again, since I'm talking in a generic way, I was explaining in this way. Okay. Part 12 of the latest ISO 26262, the confirmation measure has been reclassified for the motorcycle industry. So I2, which means the second category, okay, the second category, and then this second category has been set as the highest level of independence as compared to that of I3, which means, so I2 is being followed in most of the two-wheeler company when compared to that of I3 with respect to the motorcycle function safety, which means instead of three, they are following two, which means the confirmation measure is be performed by a different person, not reporting to the same direct superior. Suppose, which means I can say it is a cross-functional team within your own company. So it implies that the confirmation measure will be performed by a person from a different team who does. So it's almost same, right? Okay. Now again, so Hara is the heart of anything. And but again, here there are some few modifications made to the process of ARA in the case of motorcycle application rather than ASL activities in four-wheeler application. So here the safety in a two-wheeler ecosystem depends on multiple external factors. Okay, it also depends on various factors, right? Which is not part of the vehicle. Okay, helmets, wearing helmets is it's outside, it's not in your scope. Okay, even the protecting gears or training. So this is totally it depends on the complete ecosystem where the helmets, the protective systems. Okay, and so here the rider has an enhanced responsibility to keep the two-wheeler safe while riding. And moreover, in the case of four-wheeler, at least you have the airbag, and you also have the airbag warning system, alarm system, if in case if the person is not wearing the airbag. So they also have the alarm system, right? Um, so those things also, that's why it's called, it's totally out of scope. The safety is depending upon many external factors in the case of two-wheeler. And the last point here is SOR may also result from the motorcycle's behavior and not necessarily from a failure. See, that's what, like, one is with respect to the vehicle component failure and all, what we are dealing with, the frame failure or uh, the suspension failure or the engine failure, okay, or performance pickup issue. Those things are a failure. But when you're talking about SR, the motorcycle behavior is important. How the person is driving the vehicle, with helmet or without helmet, or how is he turning in a vehicle with the maximum speed. Okay, so the behavior of motorcycle is totally completely different. And they also do a lot of they also threaten the people, like by their behavior of vehicle, by their riding behavior. Okay, so on the side, this assault is totally depends on the external factors rather than the failure which is coming from the individual components in the two-wheeler application. Okay, so in the case of this is an example on how the ecosystem affects the rock. Say, for example, in the case of a passenger car, which is inherently designed to navigate safely through snow or ice or on the road. However, a motorcycle is not, right. So motorcycle is totally different. Whereas in the case of passenger car, it is when the vehicle is running in snow or ice road condition, it navigates safely. But skidding can happen, or when the vehicle is when the road is even the road pattern also varies. Yeah, see you can have a very good comfort when you're running the vehicle in a four-wheeler, in a car, when the vehicle is running in rough road, rather than the vehicle running in a two-wheeler application in the case of rough road, where you have a lot of bumps. Okay, where the road is not even. Okay. So if the rider decides drives off-roading or drives in a such situation during a heavy snowfall, he or she should is going to accept a high degree of risk. Okay. Uh, so these are that's why this is how the ecosystem affects the aura. Okay, it's not related to the vehicle, but it's even the driving pattern or see, road condition is not, it is again going to be ecosystem, and it's away from the vehicle. When you say away from the vehicle, it's not in the scope of manufacturer. Okay, see, manufacturer will try to do the vehicle with all the safety within this one, but again, when compared to the ecosystem, the manufacturer may not be knowing how hard the rider is making the vehicle and what condition he is running. Is he running the vehicle in city condition or city plus highway condition or highway condition or a hilly condition or a bump condition or a rough road condition uh, or the road is very curvy you call, right? Canterbury, you call, you have different scenario. You also have the composite durability running. Okay, and you also have the cross highway durability. So that's why you also do a lot of testing internally. But even though if you do all the testing, the pattern of um, pattern of the rider running the vehicle, the customer running the vehicle is totally out of scope. But that's why even though they try to capture it with respect to the validation point of view, but still these are all the challenges. Okay, but again, this 2 days going to be totally more challenging. So that's why I'm going to give you how this hara is totally how the ecosystem is affecting the hara, and based on that, how the scenario gets changed. Okay. Uh, so that's what this scenario are outside the scope of thing, but moreover, the three important factors in hara includes controllability, severity, and exposure. See, even though the vehicle is running in bump road or rough road, how good the vehicle be controllable, how severity the exposure, how severity that failure is going to happen, and what is the exposure limit or probability of occurring that. Okay, and even you can say for that matter, say for example, the tire wear and are getting, uh, see, even though the tire wear or you can say this tire, if you have more wear in the tire on the tire, and when the vehicle is running in when the two-wheeler is running in a road where you have the wet condition. Okay, uh, you can also correlate that it might be some slip, the tire slip also can happen because of the wear that it happened over the period of time. Okay. That's why it depends on various scenario. Okay. But however, it is very important that the manufacturer have to see how best they have to consider. So what I was telling, the examples all are related to mechanical, but again, when it comes for the electronic aspects, electrical electronic aspects, which these things are happening. So that's why we also need to give some safety features. So if in case dual safety features also you need to go. If in case one circuit fails, you also need to go for a second circuit. That's what, like in the case of brake application and all, you have the hydraulic brake system even for a two-wheeler or for some application. In the case of four-wheeler application, where what you do is you have a dual circuit, right? So if in case one circuit fails, the other circuit will give you the, the chance where you can stop the vehicle. Okay, so that's why you also need to ensure that dual means the safety is not getting affected. Even though if there is a failure of primary failure also going to happen, it will not affect uh, the overall thing. So here, even though there is a failure, there is no hazard is going to happen, right? Because one circuit completely fails, but still the vehicle gets stopped. Okay, but even though there is a failure, there is no hazard. Okay, and you know that this failure can be because of some error or because of some fault. That's why I told you all failure or all error or all fault may not lead to failure, and all failure may not lead to hazard. But again, it's very important that uh, how best you are reducing the fault with respect to the system or component that will have a very good impact on the overall safety features. Okay. Okay, so coming back to the motorcycle specific horror, um, so again it is getting repeated. So more on the rider behavior than the machine components for mitigating risk. Controllability of motorcycle like specific hazard events place a more focus on the rider. Okay, and this horror leads to the determination of MSAL, motorcycle integrity level, which is also a counterpart of ASIL. The worldwide established level of technology in the motorcycle industry suggests that ASIL classification it's inappropriate for motorcycles. So an alignment should be there between the MSAL and the ASIL classification, and it should also meet the requirement of ISO 262, which is to the worldwide capability of the motorcycle industry. Okay. Okay. Some again motorcycle specific error. So there are some operating scenarios. So here, say for example, malfunctions are considered in operational mode when the vehicle is correctly used, and when it is incorrectly used in a reasonably foreseeable way. Okay, for example, a road race or a motor cross or a trail events are not considered normal motorcycle use conditions. Okay, uh, you know, because it's totally the racing in the totally completely different, right? Even the trial events. Okay, these are not considered normal motorcycle conditions. And here you need to consider hazard operability condition. See what is the operating condition which is leading to the hazard. Okay, so here what you call hazard, this hazard can be used to identify the hazards and operational scenario. This operational scenario is totally very important thing, which the manufacturer is totally not having the control. Okay, and you also have some annexer in the part 12 where it lists the severity scale based on the standard A standard, which also includes the exposure, what is the duration of that, what is the frequency, or what is the probability of the occurrence. Okay, exposure basically. So, for example, you're assuming, right, for controllability that the driver is trained, experienced, and in good condition. Say, for example, even the controllability is very important, like severity, exposure, and controllability is important, right? If the driver is well trained, he can control it in a very good way, right? And if the driver is experienced, he can also control it. And what happens if the driver is not trained for a specific scenario, or if the driver is novice, or if he's very new, the controllability also varies, right? So this is how, but again, that's where the operational scenario is important to identify. And again, that's why there is one annexes, which also this, where based on that, the severity and this exposure also comes into picture. Okay. Okay. So the scenarios should not be too many. Okay, there should not be too much scenario, which makes analysis vague. Okay, it should be and the exposure rare. So you should not make like this, and it should not be too few also. Okay, insufficient safety measures might be considered. So it should not be too high or it should not be too few. The best way is to aggregate similar scenarios to the list as relevant to the possible to use. That's what like customer use case you call, right? On what basis the customer is using. So that scenario you can do it. It should not be too much overthinking also, because but again, except the specific driver they do, it doesn't mean that all the driver will do. Okay. Yeah, normal motorcycle is not expected to travel on bad roads at high speed. Okay, so this is again an example. Okay, in a similar way to ASIL, this MSL is also determined by three factors: severity, exposure, and controllability. Okay, this I told you, right? There are four MSL values, which is named A to D. So MSL A is the minimum level of risk, while MSCL D, you see, basically it's going to be C, not D, right? So because I told you ASIL D is letter to C, so in that way it is MSL C is going to be maximum. Uh, and again, this also means that the higher MSL is going to have the stricter compliance requirements than MSLA, because it is similar to ASIL A to ASIL D, right? When determining MSL, there are also a fifth option. You also have the quality management, and this is to be note that there is there is no safety requirement for that component. Okay, there is no safety requirement for the quality management component. That's similar to the one what we have for ASIL quality management. And however, it's generally still recommended that you need to comply with the requirement in order to improve the quality of the product. Okay, so this is what the mapping I was telling. Uh, so the output of the HARA for a motorcycle is nothing but the MSIL, and the motorcycle counterpart is, which is the counterpart of the ASIL. And you need to have the method and approach which is used to perform the HARA for motorcycle, which is similar to the raw passenger cycle. And here you are comparing the ASIL to MSIL, and you are going to map it. So here, for example, if you are considering ASIL C, I'm putting in a different way here. Just see here. We are taking the ASIL C in the case of a passenger car, it is equivalent to that of MSIL D, which is the maximum value for MSIL, which means, see, I told you ASIL D is not there for for a motorcycle application. Okay, so you are considering only up to ASIL C. Okay, which means ASIL C is nothing but it is equal to MSLD. Okay, and you also have the D extra features. I have told you, right? You have a lot of extra features because of four-wheeler, and even the requirements, performance, operating condition is totally different. So that's why you also have one more extra risk integrity level, but that is not applicable for the motorcycle. But still, you are correlating ASIL C to the maximum MSLD. Why mapping is done? This is very important here. This mapping of MSL to ASL helps the motorcycle industry to develop the hardware or software components in accordance, which is getting mapped with the ASIL grade. Okay, and before the safety goal or derived at MSL, it also needs to be mapped to the corresponding ASIL value. And the reason behind here is, you also have the product development phase, which is a part of part 4. It's still relevant, and it is also relevant. It's also applicable for a motorcycle application, and also it's based on the applicable requirement as well. So that's why it's very important that you need to do the mapping for a motorcycle application. Okay, and basically the key aspect here is you are considering the safety goal, which is getting derived from the help of this MSAL, and that's why this mapping is very much important. How best you are going to give the safety aspects. Now again, we are going to derive the MSAL. So this is similar to that of ASAL. So which is the risk, that it is a product of severity, frequency, it is nothing but exposure, okay, the probability, and then the controllability. So this is what we call this as SIL. And you know that exposure is nothing but the measure of the possibility of the vehicle being in a source or a risky situation, which can cause harm to the people and then the property. So this is nothing but the probability. The possibility is nothing but the probability. Measurement of possibility is nothing but the probability of the vehicle being in a hazardous or a risky situation, which will, that can cause harm to the people and the property. And next comes the second category called the controllability C, which determines the extent to which the driver of the vehicle can control the vehicle if the safety goal is breached due to the failure or malfunctioning of any automotive component being evaluated. Say, for example, if there is any failure or any malfunctioning, okay, of any brake system or a steering system or a suspension system or a chassis system or engine system or a transmission system or a battery system, okay, any component for that matter or any system for that matter, if there is any violation with respect to the safety goal, how 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 the how best the driver of the vehicle can control the vehicle. Okay, that's how the control comes into picture. So this is what we have seen. The risk assessment, risk is nothing but the product of severity, frequency, and then the controllability. And now, before going for this, I'll just tell. We know that severity, exposure, and exposure is nothing but the probability or the frequency what has been shown in the previous slide, and this is the controllability. So we have 3 levels in severity, right? So which is nothing but light and moderate injuries, and S2 is nothing but severe and life-threatening injuries, which is nothing but the probability of survival. And the S3 is going to be the life-threatening injuries and the fatal injuries. And when you say the exposure, we have 4 levels in exposure. One is going to be very low exposure, medium exposure, and high exposure. Okay. And when you say the controllability, you have 3 levels of controllability. One is easy to control, very simple to control. C2 is nothing but normal to control, and C3 is nothing but it's going to be difficult or uncontrollable. Okay. See, now you have the various things, right? Quality management, QM, A, B, C, D. This is what applicable for the four-wheeler application, or what I can say, for part 1 to part 11 for a passenger car or for a truck or a heavy-duty vehicle. So this has been applicable. This table has been applicable. Okay. And we also know that lower risk is going to be for low ASIL A and high risk for ASIL D. But what we have seen currently now for a motorcycle, there is a mapping we have done, right? So where we have what I have told is ASIL D So acyl C is nothing but going to be MSIL D. So when you say acyl C here, acyl C is going to be the highest rating for motorcycle. So this is going to be severe, okay, and acyl C this is also going to be severe. So when this is also going to be severe. So when I say for a two-wheeler application, motorcycle application, if the controllability is going to be C3, where it is going to be difficult or uncontrollable, and if the probability of or exposure is going to be high, and if you have a severe and life-threatening injuries, but the probability of survival is there, then this is coming under MSALC. Sorry, uh, yeah. Just before this, what I will do, I will show you the mapping so that you will understand this. Okay, this is the mapping. Okay, so this will help you to understand. See, when you say yeah, okay, so I will explain this, then I will explain it so that it will be easy for you to understand. Okay, so you see here, this is the mapping. This is the mapping. We have quality management A, B, C, D, right? This is the normal thing we have. Okay, but when you're mapping it, see here, I told you acyl C is the highest one, which is not but MSAL D. Okay, so when I say acyl C, which is getting mapped, which is equal to MSAL D. So here it is C, here it is C, and here it is C. So this is nothing but MSILD, which is nothing but the highest risk for the motorcycle. Okay, and similarly, the highest risk for motorcycle will happen when you have the C3, E3, where the probability is going to be medium, and you're going to have the S3. And also, if you have S3, and the controllability is going to be normal, and then the exposure is going to be E4. Even in this case, also you have SLC, which is nothing but MSLD. So here, when you're going for a mapping of MSL to ASL, so you have QM A, B, C, D, and here in this case, you see here there is two interesting factors here. I told you you don't have acyl D, acyl D for MSEL, which means due to some of the factors or some of the features which has been added. I told you right. Even in this case of two-wheeler application, you see here acyl A is also similar to the quality management what we have for the four-wheeler application. Okay, so this even on the lower side also you have the quality management, which means you can also see how this has been getting mapped. Okay, so in this document, it is having the table 6. This table 6 is a part of this table 6. What is being mentioned here? It's also been included in the standard. And this quality management remains quality management for ASIL, and this has been mapped to ASIL C. And so this is the minimum requirement basically. And it also implies that if the HARA, whatever it determines the MSL to be B, the component will be developed according to, you see here, this is again, so first is with respect to A, it is equal to quality management here. So when I take in the component B, MSL D, it implies that if the HARA determines the MSL to be B, the component will be developed according to the requirements which is mentioned for ASIL A. Okay. So when you are with B, you are mentioning that you are going to develop the components which will meet the ASIL A requirements. Okay. But again, to meet the requirements of any safety goal, the requirement mentioned in the part 12 will also supersede the requirements in other parts, which means it doesn't mean that you should follow only part 12, but again, it also the other requirements which is there in the other part also should be considered when you're going for this mapping or for development of the safety aspects. Let us go for one case study where the derivation of ASIL for charging a battery. It's a two-wheeler battery, electric vehicle battery. So here our assumption here is the safety goals associated with the battery is a more critical consideration to be evaluated as per ASIL, which is more than a battery itself. And here the overcharging of a battery is happening at a speed below 10 km per hour. which is not a serious serious situation as the one which we are overcharging at very high speed. Okay, and you will see here the possibility of overheating and consequent fire could also be high here. So let's see the scenario. One first condition, vehicle condition is vehicle running at less than 10 km/h, and the second scenario is where running speed is going to be between 10 to 50, and the third one is going to be greater than 50 km/h. Okay, and what can be the cause of malfunction? The charging of battery pack beyond the allowable energy storage can be the cause for malfunction. And what can be the possible hazard? Okay, the overcharging may lead to a thermal event. But what happens? The overcharging which leading to thermal event, which means the fire is going to happen. Okay, so the overcharging of a battery at the speed below 10 km is not serious. That's what was mentioned. And you see here, when it is not serious, it's coming under as the A category, because overcharging is leading to the thermal event, and the reason for this hazard is charging of battery beyond allow. You're charging the battery beyond allowable energy storage. Okay, so that's why you know that when the speed is higher, you also have the high risk. Okay, so that's why it is one example of the determination of charging the battery for two applications. Okay, let us going for the modified method for the vehicle integration of the testing activities. Here, the changes what they made in the ISO 2652 are not only confined to HARA and actually, but also it permeate to the testing activities. Okay, so there are a lot of major modifications is been made in the product development at the system level with respect to the motorcycle. So you have the table 7 and table 8. I will explain in the next slide. The next slide is going to have the table 7, which is for the correct implementation with respect to the functional safety requirement at the vehicle level. You also have the test method, which is mentioned in the table, which will give the preference over the test methods, which is being defined in the part 4, part 6, and also on part 8 of ISO 2662 standard. And this is only for motorcycle function safety. And table 8 is also going to give you the method to ensure that you are going to have the correct functional performance, accuracy, and timing of the safety mechanism at the vehicle level. And you need to follow these testing methods, which are highly recommended to fulfill the safety goal of the motorcycle. Okay, let's see what is that in the table. This is table 7. This is table 7. So you have 4 type of testing. One is requirement based test. Second is going to be the fault injection test. Third one is going to be the long-term test. And last one is going to be the under test under real life conditions. Okay, which is a part of C and D activity. Let's see what is that. A is nothing but the requirement based test, which are nothing but the requirement based test. It gets the test against the functional and non-functional requirements. So so we need to do this test, the requirement based test for ASIL A, ASIL B, and ASIL C for the motor application, where these tests are based on the functional aspects and also the non-functional aspects. Okay, so you have various functions, right? Basic functions, secondary function, one-time function, order time functions, design functions. So all these functions should be tested. That's why it's called requirement based test. And this is applicable both for function and non-function. Say, for example, you have you may have coating aspects. Coating, what is the function of a coating to prevent corrosion? But is that going to be the functional or non-functional? For a main function to happen, sometimes the coating is not a basic function, or it's not a main function, but still it is required with respect to the corrosion, or when it is exposed to atmosphere, it should not corrode. Okay, you should categorize the function based testing. Okay, it's not when you say requirement based test, it's nothing but function based test. And even there, it doesn't mean that we are only testing the function based test alone. Even we are also considering the non-functional aspects as well. Okay, and the second test is nothing but the fault injection test. So here what we are doing is we are manually introducing some fault into the item. Okay, Say for example, I told you right for a brake application, if one circuit fails, the other circuit should work. What I'm going to do is I am going to manually make a fault to one circuit to check that whether the next second circuit is working or not. The double circuit, what I call, what I was telling. So here, this test can be done with the item where you have a special test interface, or you are having the special communication device or elements where you are going to introduce a fault injection system to improve the test coverage of the safety requirement. You are going to cover the safety requirement because when you are considering the normal operation safety aspects, what it is not being when you are not in, see what happens in the requirement testing. If there is no issue with the safety functions or non-function, the test will get passed. But in the case of false injection system, I'm introducing a fault manually to check, even though if there is a failure, whether is it going to affect my safety violation or safety requirement or not. That's why the very critical part I have taken you is a break one where you have a double circuit. If one circuit fails, will the other circuit will it operate or not? So that's why we are doing this as a kind of fault injection test. And the third thing is a long-term test, uh, and where here the user test under real life condition, which is similar to a test what has been there in the field. But again, you say, for example, I will give you an example of the lighting system where the headlight, the tail lamp, indicator lamp. Okay, so this might be running for 5 lakh cycle. You say one on-off cycle. Okay, one time you are oning the headlamp, tail lamp, and also the indicator lamp. You are doing it for 5 lakh times, so it's nothing but 5 lakh cycles. So this is nothing but a long-term test. And similarly, you can also do some tossability test or bump test, or you also can do the durability tests, which are having more, which are considered to be more, and that's also considered as a long-term test. But even though if it is long-term test, but still it can be considered as a field experience. Uh, and again, also it depends on the samples, number of samples, for how much testing you are doing. Are you going to test it one samples or two samples or three samples? See, that's why you, if it is a one sample, you need to do very long durability, which is the number of cycles or number of kilometers or number of targets should be much more higher. And that's why you have the variable distribution, right? How you are testing it, what's the frequency of testing, what's the level of testing. So those things also to be considered. But again, long-term test is also based on the sample size as well, or the matrix. Okay, and these tests will also can have limitations if necessary to ensure the safety of tests. For example, if you are going with additional safety features, or if you're in the case of if you're having some actuators, okay, and how if you're disabling it, okay, how it is going to perform. And but one more problem is long-term test can be infeasible for some application for the motorcycle, and user test can be also infeasible for motorcycle. It depends again. It also depends on uh, uh, the real life conditions during everyday life. But again, going beyond the certain assumptions, testing that is also infeasible. Okay, because the OEM is not ready to take the risk, because it's not just testing alone, it also calls for the safety issue of the person who's testing as well. Okay, so these are all the things which is the correct functional performance, accuracy, and then timing of safety mechanism at the vehicle level. So I told you about the different performance tests, long-term tests, user tests, and the real-life conditions, fault detection test. You also have some error guessing test. So you're guessing some error and you're going to test that. Okay. Say for example, over voltage or over current, or under voltage, under current, or voltage drop. Okay. Or deep sleep current. Like say for example, the battery getting completely drained off, or not getting charged. So you are guessing some error and you are testing, right? And say for example, the brake fluid or the pressure at which the brake applies. So if you're guessing some test, you can do that. And you're also going to test derived from the field based on the field experience or field failure. So what you are going to have is, see, I told you A, B, C is the highest. Sorry, just for time being, I've taken you C. I'm not taking the D. D means it's applicable for all the things, but you see here the performance test is mandatory for SLC category. Long-term test is mandatory for SLC category. User test under real life condition is also mandatory for SLC category, and fault injection test is also mandatory for double means it's very highly recommended, highly it's important. And error guessing is also SLC, and test derived from field experience is also applicable for SLC. So when it comes for SLA, performance test, long-term test, and under test, user test under real life condition is applicable. When it comes for SLB, all the things you need to do, but SLC is, you can see how it has been taken into consideration. So I will give you an example of error, because we have seen all these things previously. So the the last two I will explain, where the error guess test uses the expert knowledge and the data collected through lessons learned. It also helps us to anticipate the errors in the system. Then a set of systems tests are being done along with adequate test facilities, and it is designed to check for these errors. Error guessing is an effective method which also gives the tester who has the previous experience with the similar systems. Okay, and the test derived from the field experience and the data gathered from the field also need to be taken here. So the safety validation covers the controllability and the effectiveness of the external measures, and the effectiveness of the elements for the other technologies also can be considered. For example, the mechanical component that prevents the malfunction can be validated on the final vehicle at a later stage. That's why you also have the various stages of the vehicle validation as well. Let's take an example of a case study where the Honda 1800cc Goldwing ran away. Okay, so Honda, this is the Honda luxurious Goldwing, having the flat six-cylinder engine and having 7-speed dual clutch transmission option. And this Goldwing also has a airbag safety option. Also, this also have the airbag safety option. On 2004, what happens? An accident has happened where the victim claims to have an uncontrollable race of the engine for the malfunction. Okay, this is the incident which has been reported by the victim on 2004, where the person has claimed to have the uncontrollable race of the engine. They don't have the uncontrollability. The controllability is not there. It means difficult to control. You can consider that as a C3. Okay, as soon as the engine starts, what happens? The bike moves at maximum throttle and moves for 58 feet. You see here, sudden this one, like even when you start itself, is going for a maximum throttle and moves for this much speed, and what happens? It hits the curb, and the person who is riding has been thrown away, is thrown off. Okay, and here what happens? The victim has minorly, as it was the speed is very limited. Okay, very low traffic zone, and gets a new bike as simple. Okay, but again, who is the affected party? The affected party is, yes, you see here, the person who has done this. Okay, who is ridden this or who has driven this. The OEM is again roasted legally and on media faces and lots of brands naming, and again loyal customers also going to get loose. Okay, so here the learning here is, uh, this is again a safety issue, right? So, say again, I can also tell one more example where you have the motor reversing issue. Okay, see, normally when you put a forward acceleration, sometimes because of the reverse motor, what happens? The vehicle goes instead of forward acceleration, the vehicle goes in the reverse way. Even this are also some of the failures happen in some of the vehicle application. Okay, so all these are part of safety issue. Okay, where the OEM have to predict all these things, and they have to develop such a way, uh, the vehicles, when you're forwarding the vehicle should not go reverse. Okay, even see the high speed in the forward, when you're going for a reverse at the same speed, if it is getting manipulated, if it is getting uh, reflected in the reverse, what happens? That is also a danger one. And similarly, when you're giving the throttle, and immediately the vehicle moves at a maximum throttle. Again, you see here, and it moves for 58 feet at the start itself. Okay, again it is hitting the herb. These are all a safety issue that needs to be taken care. And general malfunctions that make the motorcycle crash. These are all the general things that most of the experience the motorcycle. Not even the not even the most experienced. Even the person who's new, they experience these things like engine getting malfunctions, the defected tires, or the engine integrity, or the fuel tank flush, or a brake error, or improper handle, or even the thermal runaway also for a EV vehicle. Okay, and let's see this one, like the malfunction, how it can happen. The malfunction in the engine, it's one of the top motorcycle malfunction as at fault for the motorcycle accidents. And that two types can increase the accident chances. It can be because of lack of lubrication or the wrong kind of lubricants being used. So, for example, synthetic oil, where you're also going for a non-mineral based oil like glucose oil or value, which can be removed by contacting a mechanic. And the next can be the incorrect lubrication application, which can also lead to the engine failure, leading to the overheating of the engine cylinder basically. So when it overheats, what happens? This also lead to the malfunctioning of the engine. Uh, so all that's why you should also take a precautionary where you should also monitor your oil level. So you should perform a maintenance, annual maintenance and inspection. So at least once in a year, but also every 120 kilometers or 75 miles, you should also level up your oil level. Okay. So these are all the things that, and even defected tire or defected tire also can is most of the time this happens, right? Where the wear happens, it calls for a traction issue. Okay, that's what I given you one example. The defected tires running in a wet condition during a rainy season, it calls for a slip. The slip is going to be high. So this again going to be a risky one. Where you can see the slippery condition can cause an increase in the chance of a motorcycle collision due to the high risk of loss of control. You're going to have the control is going to be lost, right? And again, you're going to have a dangerous movement during the cornering. Even the cornering also, the skidding can happen, or uh, you lose the traction. When I say skidding, it's not it is vehicle getting hit away, but it's basically the control, the loss of control with respect to traction point of view, where the tire is slipping. Uh, okay, so you also have the defected wheels, which also have one of the malfunction. When you're not taking care of the wheels, it also reduces the integrity and traction, and also the thickness. As a result of that, many motorcycles is becoming a victim for a motorcycle slide accidents. And these are something structural failure can also happen. See, the failure can be anything. It can be the structural failure, or it can be the environmental failure, or it can be the um durability failure, the performance failure. There can be performance failure or environmental failure or the durability failure. Okay. It can be or the combination of these three resulting in the overall safety failure of the vehicle. So here one example is the crack in the frame. Um, See the crack on the frame can also cause the engine to vibrate. Okay, and the structure weakness can also eventually influence the performance, and it can also resulting in an accident. But again, the reports also says that such accidents are also fatal. So how you can see you just have to do some injection based some testing. That's what like error based testing. So for example, fault injection based. See what you can do is you can the OEM can they can they can create a frame where they can also manually create a manual crack, and then they can uh, test that is there any because of that is there because of that crack is there any accident means any issue with respect to performance. Okay, they can also do something. See what they can do, they can put a dummy in a vehicle. They can put a dummy, two dummy, one in the front and rider and pillion. They can put two dummies and they can run a bump test where the vehicle will be running in a bump cam drum. Okay, and then they can put a dummy and then uh, they can run the vehicle at 15 kilometer per hour or 20 kilometer per hour, and they can also manually, they can also induce the vibrations artificially. Okay, and then they can see, because of that crack in the frame, is there any failure is going to happen or any accidents is going to happen. So but again, it is not a real human, it's going to be a dummy. So even in this way also you can think of it, but that's why you need to consider testing where the fault based or error based or the requirement based or the function based or non-function based, how you are going to test that, that is very much important. Even the gas tank flaws, even this also very dangerous, that the tanks getting leaked also cause the deadly accidents, and the leakage can also form it also creates a consequences, lot of consequences. And even the handlebar, if you don't have the improper handlebar, what happens, um, it can, you don't have proper controllability. Okay, so the handlebars will be perfect so that you can steer the vehicle as per your thing, and you can have the proper handlebar. And brake error, this is a very important thing, which is with respect to the safety issue. Yeah, yeah, high speed crash due to the brake failures, malfunction that causes a severe damage to the rider. As a motorcycle does not protect the rider doing using a vehicle's frame, brake failure can also be the last moment of the victim. Okay, so that's why you need to have the better system such a way the chance of failing. See, at least one should be secure. Okay, if there is a failure in the rear brake, the front brake should work at least. Okay, so because brake system is totally high, it's coming under SLC for a motorcycle application, because this comes in SLD in the case of passenger car, but here uh, it's on the other side. Okay, but one brakes test increasing with chance accidents almost 65% controls, the possibility also high. So hence, this type of things you need to take a very utmost important thing. See, according to National Highway Traffic Administration (USA), malfunctions can lead to a motorcycle to lose the controllability by up to 67%. Okay, the controllability of the rider, it is going to be up to 67%. Unfortunately, many bikers or riders, they don't have they hold expert knowledge. It may become more challenging for a motorcyclist to notice very few invisible malfunctions like engine integrity. These are some of the things which is making them invisible. Uh, so, for example, the first function, what I was telling, the engine integrity, it can cause the motorcycle crash if the brake on a, even also if there is any bike, any fault in the brake also can cause your motorcycle crash, and it can also happen um, for you when you're not aware of wear and tear over time, and uh, how it is going to happen. So that's why it's all integrated, basically integration. Um, and again, the second flaw, what you're telling, it can also potentially lead to the motorcycle if your clutch is getting damaged somehow. Okay, and say for example, if you're having a faulty clutch and when you don't switch off the engine before making adjustment to your vehicle, and even even the tire replacement for that matter. See, it's not, you not say only because of one reason. Even there can be some integration of 2 3 issues. Here they have taken a combination of two issues. Like one can be the way the tire issues, and another can be the clutch issue. Okay, and even here, what again they taken is an example of a fuel tank getting burst because of this. Yeah, and again, the concerning matter is that these problems can suddenly show up due to the long hurt from motorcycle. So again, it can be the can be one reason or the multiple reason or combination. Okay. Okay, so always we need to check for a recall where the recall means the safety information should be such a way about the Rafata vehicle, and you should also have some defective mechanical parts in question. Okay, and the most affected areas of the motor vehicle. Finally, you should also see the way forward for moving the vehicle forward without, even though there is a fault or failure, does not be any hazard. Okay, any fault. That's why the fault injection test, those things are helping. Okay, so the summary for this part 12 for ISO 26262 for a motorcycle application is that this function set is applicable for a motorcycle, which is a part of part 12, and you are having the freedom from unacceptable risk, and this is only for two-wheeler application, and you have the MSIL, and this two-wheeler also needs to require to perform the RA, which is same as that of automotive safety, and you have the severity S1 to S3, exposure E1 to E4, and controllability C1 to C3. Based on that, the SLA, SLB, SLC, and SLG is calculated. But again, for this MSL, we have only SLC. MSLD is equal to SLC, and MSL C is nothing but SLB. MSL B is nothing but SLA, and MSL A is nothing but quality management, and MSL quality management is also equal to SL quality management. Okay. So MSL to SL is similar because the mapping is important, and so SLC is the highest level for the tool application. And so this is a summary that we have seen, and thank you and thanks all for joining. Uh, so I look forward.